Imagine that somewhere in a laboratory, a physicist writes one final equation on a blackboard. The equation explains gravity, it explains particles, it explains light. It reaches backward toward the earliest moment that our instruments and theories can describe. Then the physicist puts down the chalk and announces, "Islam has been proven." Could that ever happen? Could a telescope discover Allah? Could an experiment identify the Quran as revelation? Could the laws of physics demonstrate not only that a creator exists, but that Muhammad was his messenger? Or are we asking physics to answer a question that no physical instrument was designed to answer? Welcome to the Guided Hour, where every journey carries a story and every story carries guidance. Today, we journey through one of the largest questions the human mind can ask. Can physics prove Islam? This question is not foolish. It comes from something deeply human. We look at the night sky and feel that it is saying something. We learn that the light reaching our eyes may have traveled for millions or billions of years. We discover that the matter inside our bodies was formed through processes involving ancient stars. We find that the same mathematical laws appear to operate in distant galaxies and in laboratories here on Earth. Then we wonder whether this order is only a fact or whether it is also a sign. The Quran invites human beings to look. It directs attention toward the heavens and the earth, the alternation of night and day, the movement of the sun and moon, the creation of life, the falling rain, and the order that surrounds us. But invitation is not the same as simplification. The Quran does not tell us to invent evidence. It does not require us to pretend that every scientific discovery is a direct translation of a verse. It asks us to observe, reason, remember, and recognize our responsibility. That means we must begin by understanding what the word prove actually means. In mathematics, proof has a strict meaning. A mathematician begins with definitions and accepted foundations. Step by step, a conclusion is demonstrated through logic. If the reasoning is valid and the starting assumptions are accepted, the result follows necessarily. Physics works differently. Physics observes the world. A physicist develops a model, calculates what the model predicts, and compares those predictions with measurements. When repeated observations agree with a model, confidence in that model grows. But physical theories are not protected from revision. Newtonian mechanics described motion with extraordinary success. It still works extremely well for many ordinary situations. Yet relativity showed that Newton's description was not complete at very high speeds or in strong gravitational fields. Relativity did not make every bridge designed with Newtonian physics collapse. It showed that the older theory was an approximation within a particular range. Science often advances like this. A model explains what has been observed. New observations reveal limitations. A deeper model is developed. The older model may remain useful, but it is no longer treated as the final description of reality. So when someone says, "Physics proved this," they often mean that a claim is strongly supported by experimental or observational evidence within a defined scientific framework. They do not usually mean that no future discovery could ever refine the explanation. Now consider a second kind of reasoning. Suppose you walk into an empty room and find a glass of water standing in the center of the floor. Physics can describe the water. It can calculate the pressure at the bottom of the glass. It can model the motion of the molecules. It can explain why the glass reflects light. It can estimate how quickly the water will evaporate. But none of those equations automatically explains why this particular glass of water is in this particular room. For that, you may need historical information. Perhaps someone placed it there, perhaps a pipe leaked, perhaps it was part of an experiment. Physical laws describe what water does under certain conditions. They do not, by themselves, give the complete history of every glass of water. This distinction matters. A scientific explanation may describe a mechanism without providing an ultimate explanation for why that mechanism, those laws, or that reality exists at all. Physics asks how physical systems behave. Metaphysics asks what kinds of reality exist and why anything exists. History asks what happened. Moral reasoning asks what ought to happen. Revelation makes claims concerning Allah, worship, human purpose, accountability, and realities that are not reducible to measurements of mass, energy, position, or momentum. These fields can interact. They can inform one another. But they do not become identical simply because they discuss the same universe. To understand what physics contributes, let us begin with what it has actually discovered. For much of human history, people looked at the stars without knowing how distant they were. The night sky appeared permanent. Generations were born and died beneath familiar constellations. Then telescopes became more powerful. Astronomers learned that many faint objects in the sky were not small clouds inside our own galaxy. They were enormous galaxies separated from us by almost unimaginable distances. Light from distant galaxies also carried information. When astronomers separated that light into its component wavelengths, they found patterns. In many distant galaxies, those patterns were shifted toward longer, redder wavelengths. The farther away a galaxy was, the greater this cosmological redshift generally appeared. The universe was not simply a collection of objects sitting inside a motionless emptiness. The large-scale distances between galaxies were changing. Space itself was described by models of cosmic expansion. When scientists use the phrase, the Big Bang, popular imagination may produce the image of a bomb exploding at one location inside an already existing space. That picture is misleading. The standard cosmological model describes an early universe that was much hotter and denser than it is today. As the universe expanded and cooled, particles combined into nuclei. Later, electrons could remain bound to nuclei, allowing stable atoms to form. Light that had previously scattered through the hot plasma could then travel more freely. We detect that ancient light today as the cosmic microwave background. It reaches us from every direction. Tiny variations within it contain information about the early conditions from which galaxies and large-scale structures eventually developed. The evidence for a hot, dense early universe does not depend on a single observation. It includes cosmic expansion, the cosmic microwave background, the distribution of large-scale structure, and the abundance of light elements. Together, these discoveries transformed modern cosmology. The observable universe has a history. It has changed. It is not physically static. Does that prove creation? Not immediately. This is the first place where careful language protects us from a weak argument. The Big Bang model describes the evolution of the observable universe from an extremely hot and dense early condition. It does not, by itself, explain why there is a universe. It does not automatically describe creation from absolute nothing. It does not yet provide a complete, experimentally established account of the earliest possible instant. When equations based on general relativity are extended backward, they can reach conditions in which quantities become singular, and the theory can no longer provide an ordinary physical description. That may indicate an absolute beginning. It may indicate that the theory has reached the boundary of its valid application. A successful theory of quantum gravity may change how that boundary is understood. Scientists have proposed inflationary models, bouncing cosmologies, cyclic scenarios, quantum creation models, and other possibilities. These proposals are not all equally supported. None has given humanity a laboratory recording of absolute nothing becoming a universe. There is also an important mathematical result known as the Borde-Guth-Vilenkin theorem. Under a specific condition involving positive average cosmic expansion, The theorem shows that certain expanding spacetimes cannot be extended indefinitely into the past along particular geodesics. In simpler language, inflation alone cannot always provide a complete description extending forever backward. A past boundary remains. But notice what the theorem does not say. It does not say that the boundary is Allah. It does not describe what exists beyond the boundary. It does not prove creation from nothing. It does not identify a religion. A scientific theorem can show that a model is incomplete without supplying a complete metaphysical explanation. That incompleteness is important. It may strengthen the question of cosmic origin, but it is not honest to add conclusions to a theorem that its mathematics does not contain. Now we reach a deeper question. Even if some future model described a physical state before the hot, dense early universe, would the question of creation disappear? Suppose scientists discovered that our universe emerged from an earlier physical field. We could then ask why that field exists. Suppose our universe emerged from another universe. We could ask why that universe exists. Suppose there is a multiverse containing countless regions with different physical conditions. We could ask why the multiverse exists, why it has the structure that permits universes to form, and why it follows any laws at all. Moving the physical explanation backward does not automatically remove the metaphysical question. A longer chain is still a chain. A deeper mechanism is still a mechanism. This is where Islamic thought makes a distinction between created things and the creator. Created things are dependent. Their existence is not explained by their own nature. They have properties they did not choose. They occupy conditions they did not establish. They change, they interact. They can be imagined as different from what they are. Allah is not presented in Islam as one additional physical object hidden somewhere beyond the furthest galaxy. Allah is not a giant body occupying a region of space. Allah is not matter, energy, a field, a force, or a particle waiting to be detected. Allah is the creator of space, time, matter, energy, causation, and every dependent reality. That is why asking a telescope to photograph Allah misunderstands what Muslims mean by Allah. A metal detector cannot prove a mathematical theorem. A thermometer cannot measure justice. A telescope cannot measure forgiveness. This does not mean mathematics, justice, or forgiveness are meaningless. It means the instrument is designed to detect a different category of thing. Consider physical laws. We often speak as though laws command the universe. Gravity tells planets how to move. Electromagnetism tells charged particles how to interact. Quantum theory tells probabilities how to behave. But equations do not stand in space shouting instructions at matter. An equation is a human representation of a regularity or structure found in nature. Writing Newton's law of gravitation on paper does not pull the moon toward Earth. The law describes a physical relationship. This leads to another question. Why does the universe possess stable relationships that minds can discover? Why does mathematics describe nature so effectively? Why can a creature made from matter examine distant stars, formulate equations, test predictions, and understand patterns that existed long before that creature was born? Physics uses the regularity of nature. It depends upon it. Every experiment assumes that the world will not change its basic rules simply because the experiment is repeated on Tuesday instead of Monday. If electrons behaved according to one pattern in one laboratory and followed unrelated rules in the next room for no reason, science would become nearly impossible. The success of physics reveals an ordered and intelligible universe. Whether that order should be interpreted as evidence of divine wisdom is a philosophical inference. Physics demonstrates the order. Philosophy asks what best explains it. Revelation tells Muslims that creation is not meaningless and that the signs within it direct attention toward Allah. Some people respond that the laws simply exist. There is no need to ask why. That is a possible philosophical position, but it is not a result established by an experiment. No detector has measured that the laws are self-explanatory. No telescope has observed that reality requires no ultimate explanation. To say that the universe is simply a brute fact is not neutral physics. It is one philosophical response to the facts discovered by physics. The believer also offers an explanation. Dependent reality exists because it is created and sustained by a necessary creator. The disagreement is not between one person who follows science and another who refuses science. Both can accept the same measurements. The disagreement concerns what those measurements mean within a larger account of reality. This brings us to fine-tuning. The phrase is sometimes used carelessly. It does not mean that scientists discovered a control panel floating in space with a label reading, "Designed by Allah." Fine-tuning refers to the observation that certain physical constants, laws, relationships, and initial conditions must fall within limited ranges for particular forms of complexity to arise. Stars require stable physical relationships. Chemistry depends upon the properties of particles and forces. Galaxies require conditions that allow matter to gather without the universe immediately collapsing or expanding in a way that prevents structure. Long-lived stars provide time and energy for complex processes. Stable atoms and a varied chemistry are necessary for life as we know it. Researchers have studied how hypothetical changes to physical parameters might affect nuclear reactions, stars, planets, galaxies, and the possibility of complex structures. Some parameters appear highly constrained. Others allow broader ranges than popular presentations suggest. Changes to several parameters together may produce outcomes different from changing one parameter alone. This subject is real. It is also complicated. The fine-tuning argument usually develops like this. First, the universe permits complex life. Second, life-permitting conditions appear restricted within a larger range of physically conceivable conditions. Third, several possible explanations are considered. Perhaps the values are physically necessary and could never have been different. Perhaps they occurred by chance. Perhaps many universes exist with different values, and observers naturally appear only in regions that permit observers. Perhaps the conditions reflect intention or design. Physics contributes to the first two stages by studying which conditions allow different structures. The final stage includes philosophical judgment. How should probabilities be assigned to possible universes? What counts as a possible set of laws? Do we possess a justified probability distribution over physical constants? Does a multiverse explain the values or move the explanatory question to the mechanism that generates the multiverse? Would a multiverse and divine creation necessarily contradict one another? These questions cannot be settled by repeating a large number from a popular video. A Muslim may reasonably see fine-tuning as consistent with the Quranic vision of measured, ordered, purposeful creation. The Quran repeatedly directs attention to proportion, balance, regularity, and the absence of aimlessness. But a responsible Muslim should not say, "Every physicist agrees that fine-tuning proves Islam." They do not. Some physicists see fine-tuning as a profound mystery. Some think future theories may explain the values through deeper necessity. Some favor multiverse models. Some reject probabilistic fine-tuning arguments because the relevant probability measures are unclear. Some see the observations as supporting design. Physics has not forced every researcher to adopt one metaphysical conclusion. That does not make the subject useless. It teaches us to distinguish evidence from compulsion. An argument can be rationally powerful without functioning like a mathematical theorem. Human beings make important decisions through cumulative evidence every day. A court does not usually possess an equation proving what occurred. It examines testimony, physical evidence, motives, timelines, alternative explanations, and consistency. A historian does not repeat an ancient event in a laboratory. Historical knowledge is built through documents, transmission, material evidence, contextual analysis, and comparison. In the same way, belief in Islam need not rest upon one equation. It can rest upon a cumulative case involving the existence and nature of the universe, the human capacity for reason and morality, the Quran's message and preservation, the life and mission of the Prophet Muhammad, the coherence of Islamic monotheism, and the explanatory power of the worldview as a whole. Physics may contribute to that case. It cannot replace every other part of it. If this episode is helping you see these questions with greater clarity, take a moment to like this episode, subscribe to the Guided Hour, and share it with someone who may benefit. Your support helps more families discover thoughtful and reliable Islamic storytelling. Now, let us return to the evidence. Few areas of science attract more exaggerated religious claims than quantum mechanics. The quantum world is genuinely surprising. Particles can be described through quantum states. Measurements produce outcomes governed by precise probabilities. Systems can become entangled so that their measurement statistics display correlations that cannot be explained by ordinary local hidden variable models. Bell tests have repeatedly shown violations of inequalities associated with local realism. These discoveries transformed technology and our understanding of nature. They do not prove that human thoughts create reality. They do not prove that consciousness survives death. They do not prove manifestation. They do not prove that prayer mechanically changes quantum probabilities. They do not prove Islam, Christianity, Hinduism, atheism, or any other worldview. The word observer causes much confusion. In everyday language, an observer is usually a conscious person watching something. In quantum physics, measurement can refer to a physical interaction producing a record or correlation. A detector can perform a measurement without a human being staring at it at the moment of interaction. Different interpretations of quantum mechanics attempt to describe what the mathematical formalism means about reality. Some emphasize wave function collapse. Some propose many worlds. Some adopt relational, informational, or other approaches. Several interpretations can produce the same experimentally testable predictions. When interpretations do not generate different measurable outcomes, an experiment cannot easily select one merely because its language sounds more spiritual. Quantum mechanics shows that nature is not always structured according to classical intuition. It does not authorize us to attach any preferred theology to the word quantum. Truth does not need scientific vocabulary used as decoration. Islam does not become stronger when uncertain physics is presented as certainty. It becomes more vulnerable when people are taught that faith depends on a misunderstanding. This brings us directly to the Quran. What relationship does the Quran establish between revelation and the natural world? The Quran does not speak of nature as a rival to Allah. It does not describe physical explanations as threats to belief. Rain can have a physical mechanism and still be one of the signs of Allah. Embryonic development can involve biological processes and still belong to creation. Planetary motion can follow mathematical laws and still express dependence upon the Creator. In the Quranic worldview, explaining a mechanism does not remove Allah. The mechanism itself is created. Its components are created. Its capacities are created. Its regularity is created. The human mind that studies it is created. Surah Ali Imran directs attention toward the creation of the heavens and earth and the alternation of night and day. It describes people of understanding as those who remember Allah and reflect upon creation. Their reflection does not end in trivia. It leads them to recognize that creation is not without purpose. This sequence is important: observation, reflection, recognition, prayer, responsibility. A report preserved in Sahih al-Bukhari describes the Prophet Muhammad rising during the night, looking toward the sky, reciting from these verses, preparing for prayer and worshipping. The sky was not treated as an alternative to worship. Looking became reflection. Reflection became remembrance. Remembrance became worship. This is closer to the Quranic relationship between faith and nature than a list of sensational claims about secret equations. Surah Al-Anbiya speaks about the heavens and the earth being joined or closed, and then being separated or opened. In the same verse, it connects living things with water. Some modern readers immediately connect the first statement to the Big Bang. There may be a meaningful resonance. The modern picture of a universe emerging from an earlier hot, dense condition can remind a reader of cosmic unity followed by separation. But responsible interpretation requires restraint. The verse is not written in the technical language of modern cosmology. Classical interpreters discussed its words centuries before modern telescopes, redshift measurements, and cosmic microwave background observations. Explanations included different understandings of how the heavens and earth were joined, closed, or separated. A Muslim may reflect on the harmony between the verse and modern knowledge. A Muslim should not claim that only one modern interpretation is linguistically or historically possible. The Quran does not need us to erase its interpretive history to make it impressive. Now consider Surah Ad-Dariyat, verse 47. Some English translations describe the heaven as being expanded. Others emphasize vastness, ample power, or the making of vast extent. The Arabic expression has supported translations connected with expansion or vastness. Modern cosmic expansion can therefore create a striking point of reflection. Yet the safest claim is not. This verse technically predicted Hubble's law with only one possible meaning. The safer claim is that the verse describes the heaven through divine power and vastness, using language that several translators render in a way connected to expansion. That is significant. It is not the same as an uncontested scientific equation. Why insist on this distinction? Because translations can change. Scientific models can be refined. Words can carry more than one shade of meaning. If faith is built upon an exaggerated claim, discovering the exaggeration may feel like discovering a problem in the Quran. But the problem was not in the Quran, it was in the claim made about it. The Quran's strongest relationship with science may not be that every scientific discovery is secretly encoded in a verse. Its deeper contribution is a worldview that makes the investigation of nature meaningful. The universe is real, it is ordered, it is not divine. Its objects are not gods, the sun is not a god, the moon is not a god, stars do not control human destiny. Nature can therefore be studied without worshipping it. At the same time, nature is not meaningless, it is filled with signs. The human mind is expected to observe and reason. Knowledge carries moral responsibility. Power without gratitude can become arrogance. Observation without humility can become blindness. Belief without truthfulness can become superstition. The Quran does not ask us to choose between thinking and worshipping. It challenges us to do both correctly. At this point, someone may ask a fair question. If the universe requires a creator who created Allah, the question assumes that everything requires a creator. That is not the Islamic argument. The argument is that dependent, originated, contingent, or created realities require an explanation. Allah is not defined as a created member of that category. Allah is the necessary, uncreated creator. If Allah required a creator in the same sense, then the word Allah would no longer refer to the ultimate creator. The question would simply move to whatever reality explains him. Islam identifies Allah as the final, independent source upon whom everything depends. Some people find this convincing. Others ask whether the universe itself could be necessary. That is a serious philosophical question, but notice again that the disagreement is philosophical. Physics describes the universe we observe as changing, structured, governed by particular parameters, and developing through different states. Whether the entire physical reality could be metaphysically necessary is not something a particle detector announces on its screen. Surah At-Tur asks whether human beings were created by nothing or whether they created themselves. This is not presented as a technical physics equation. It is a challenge to confused explanations. Nothing has no properties. Nothing performs no actions. Nothing contains no hidden energy. When physicists use the word nothing in popular explanations, they may refer to a quantum vacuum, a field, a mathematical state, or a physical framework without ordinary particles. But a quantum vacuum is not absolute nothing. It has structure. It is described by laws. It allows physical possibilities. Calling such a state nothing may be convenient language, but it can create philosophical confusion. If a universe arises from a quantum state, we may still ask why that state exists, why it has its laws, and why it possesses the capacity to produce a universe. Islamic creation does not require that the creator operate as one event inside an earlier physical timeline. Time itself belongs to creation. The phrase "before the universe" may therefore be limited by the fact that "before" normally refers to a temporal relationship. If physical time begins with the universe, asking what Allah was doing 1 hour before time began applies a unit of created time where that unit may not exist. We should now return to the central question: can physics prove that a creator exists? Physics can uncover facts that contribute to arguments for a creator. It reveals a universe with a cosmic history. It uncovers dependence, structure, mathematical order, and remarkable conditions. It shows that physical explanations remain descriptions of physical reality, not explanations for why any physical reality exists. But moving from these facts to a creator requires philosophical reasoning. The reasoning can be strong, it can be rational, it can provide knowledge. It is simply not identical to placing Allah inside a laboratory instrument. Can physics prove Islam specifically? No, not by itself. Islam includes claims that extend beyond physics. Islam teaches that Allah is one. Physics does not measure divine oneness. Islam teaches that the Quran is revelation. A telescope cannot examine prophethood. Islam teaches resurrection and final judgment. A particle accelerator cannot recreate the day of judgment for experimental testing. Islam teaches moral obligations. The mass of an electron does not tell you whether lying is sinful. To evaluate Islam specifically, additional questions must be investigated. What is the Quran? How was it transmitted? What does it claim about itself? What was the historical mission of the Prophet Muhammad? How should his sincerity, character, message, sacrifices, leadership, and reported revelation be understood? Does the Quran present a coherent account of Allah, humanity, morality, purpose, and accountability? Does it accurately diagnose human pride, fear, desire, injustice, gratitude, and repentance? How does its concept of Allah compare with philosophical arguments for an independent, necessary creator? These are historical, textual, philosophical, moral, and spiritual questions. Physics cannot replace them. This does not reduce the value of physics. It places physics in its proper position. Imagine a court investigating a major event. One expert analyzes fingerprints, another examines financial records, another studies digital communication. Another reconstructs the timeline. No single expert answers every question. The fingerprint specialist should not pretend that fingerprints reveal the moral intention of every person involved. The historian should not pretend that a document can replace chemical analysis. Each method contributes evidence appropriate to its subject. In the search for truth, physics is one witness. Cosmology describes the universe's observable history. Philosophy examines the meaning and implications of dependence, causation, necessity, and explanation. History examines claims about revelation and prophethood. Linguistics examines language. Hadith scholarship studies transmission. Moral reasoning considers obligation and value. Personal experience may motivate a search, though personal feelings alone do not establish public proof. A responsible conclusion considers the cumulative case. There is another danger we should name. Sometimes people believe that faith becomes stronger when every mystery is declared miraculous. A strange cloud becomes a sign that only one religion is true. A misunderstood photograph becomes supernatural evidence. A scientific paper is quoted without reading it. A verse is translated in the one way that matches a modern headline. Then the claim spreads because it feels inspiring. But temporary excitement is not the same as reliable knowledge. Islam commands truthfulness. A false argument does not become acceptable because its conclusion is religious. A quotation taken out of context remains misleading. A scientific claim remains uncertain even when it appears beneath Quranic recitation. The believer should have the courage to say, "I cannot confirm this." That sentence does not weaken Islam. It protects the difference between revelation and rumor. The greatest scientific minds are often surrounded by unanswered questions. What is dark matter? What is the fundamental nature of dark energy? How should gravity and quantum theory be unified? Why do the constants possess their observed values? What interpretation of quantum mechanics best describes reality? What happened at the earliest boundary of our physical models? Science grows by admitting what is not yet known. Faith should not fear that humility. The Quran repeatedly reminds human beings that their knowledge is limited. Limited knowledge does not mean no knowledge. It means that certainty should be proportional to evidence. We can be highly confident that the universe is expanding. We can be highly confident that it passed through a hot, dense early phase. We can say that fine-tuning research identifies real constraints relevant to complexity and life. We should also say that the philosophical interpretation remains debated. We can say that several Quran translations render verse 51-47 with language related to expansion. We should also acknowledge translations emphasizing vastness or ample power. We can say that Quran 21:30 creates a meaningful resonance with cosmic origins. We should not claim that it provides a complete technical description of modern cosmology. This is not hesitation caused by weakness. It is discipline produced by respect for truth. So what can physics honestly do for a Muslim? It can deepen wonder. It can reveal the scale of creation. It can break the illusion that the universe is small, simple, and centered upon human convenience. It can show that ordinary reality contains extraordinary depth. A glass of water contains molecular motion. A ray of light carries information across space. The ground beneath us participates in gravitational relationships with every mass around it. Time itself is connected to motion and gravity. Matter is structured through quantum fields and interactions far beyond ordinary perception. A night sky that once appeared like a dark surface filled with lamps becomes a view into immense distance and ancient time. These discoveries can make the words, Lord of the Worlds, feel larger in the human imagination. Not because physics measures Allah, because physics reveals more of what depends upon Him. Physics can also train the mind. It teaches patience with difficult problems. It teaches that intuition can be wrong. It teaches that measurement matters. It teaches that beautiful ideas must still face evidence. It teaches that human knowledge improves when claims are tested and errors are corrected. These habits can serve religious integrity when applied properly. A Muslim should not fear checking a claim. A Muslim should not fear discovering that a popular video exaggerated a verse. Allah does not need a false statistic. The Quran does not need a fabricated scientific miracle. The truth does not become less true when weak arguments are removed. Physics can also expose the limits of materialism, though not by performing an experiment labeled materialism false. Materialism is a philosophical claim that physical reality is all that exists. Physics studies physical reality. Its success tells us a great deal about physical reality, but the success of a method within its field does not automatically prove that nothing exists beyond that field. A map may accurately represent every road in a city. Its accuracy does not prove that friendship does not exist because friendship is not drawn on the map. A financial statement may accurately record every transaction in a company. Its accuracy does not prove that the employees have no hopes, loyalties, or fears. A brain scan may reveal physical activity associated with thought. That does not by itself settle every philosophical question about consciousness, reason, meaning, and subjective experience. Likewise, the power of physics does not automatically establish that only physics can produce knowledge. That conclusion requires an argument beyond physics. A believer should also recognize that scientific evidence is not the foundation of every part of faith. Muslims did not wait for modern telescopes before believing that the universe was created. The Quran's first listeners did not possess data from the Planck satellite. Their belief was not defective because they lacked knowledge of cosmic microwave background radiation. They encountered the Quran's language, message, challenge, moral force, theology, and the living mission of the Prophet Muhammad. Scientific discoveries may add new dimensions to reflection. They are not permitted to rewrite the foundations of revelation every time a model changes. The Quran is guidance for human beings across centuries. A science textbook must be revised as measurements improve. Confusing these roles harms both scripture and science. Perhaps the best relationship can be stated this way. The Quran tells us why the universe matters. Physics investigates how the universe behaves. The Quran tells us that creation is a sign. Physics helps us see more of the sign's detail. The Quran teaches responsibility before the Creator. Physics gives human beings power that makes responsibility even more urgent. The Quran teaches humility. Physics reveals scales and structures that humble the imagination. The Quran condemns speaking without knowledge. Science requires evidence, transparency, and correction. When each is understood properly, the relationship does not need manufactured conflict, nor does it require manufactured proof. A young listener may still ask, then how can I know Islam is true? Begin with the question of Allah. Does dependent reality explain itself? Can absolute nothing produce anything? Do physical laws exist as independent creators, or do they describe the behavior of created reality? Is the order and intelligibility of nature better understood as a meaningless accident, a necessary fact, a multiverse selection effect, divine wisdom, or some combination requiring deeper explanation? Then study the Quran. Do not study only lists of scientific miracles. Read its central message, its description of Allah, its account of human nature, its insistence upon justice, mercy, repentance, gratitude, worship, and final accountability. Study the Prophet Muhammad through reliable sources. Study how the Quran was transmitted. Study the strongest objections, not only easy ones. Ask knowledgeable people. Learn enough science to recognize when science is being misused. Learn enough Arabic, tafsir, and Quranic studies to recognize when a translation is being forced. Pray for guidance. Think carefully. Do not rush yourself into certainty through fear. Do not rush yourself away from belief through pride. Seek truth because it is true. The question at the beginning of our journey imagined a physicist completing one final equation and announcing that Islam had been proven. We can now see why that scene is unlikely. No equation contains the entire meaning of worship. No telescope verifies prophethood. No particle detector measures revelation. But the failure of physics to prove Islam by itself is not evidence against Islam. It is a recognition that reality contains questions larger than the scope of one discipline. Physics can bring us to the edge of profound questions. Why is there something rather than nothing? Why does the universe possess laws? Why are those laws intelligible? Why can matter produce beings capable of truth, moral reasoning, love, sacrifice, and worship? Why do the conditions of the universe allow complexity? Why does the Quran repeatedly direct the mind toward creation? At that edge, physics does not become useless. It becomes part of a larger conversation. The universe does not speak through words in the way revelation speaks. It speaks through order, through dependence, through change, through vastness, through the strange fact that it can be understood. The Quran does not tell us to worship the order. It tells us to recognize the one upon whom the order depends. Perhaps physics cannot place Islam at the end of an equation, but it can remove the illusion that existence is shallow. It can show us that the ordinary world is filled with depth. It can teach us to look more carefully, and when careful observation is joined with honest reasoning, reliable revelation, and humility, the night sky becomes more than a collection of distant lights. It becomes an invitation, not an invitation to exaggerate. Not an invitation to pretend every mystery is solved. An invitation to think, to remember, to seek, and to recognize that knowledge is not complete until it teaches us how to live before the one who gave us the ability to know. You have been listening to The Guided Hour, where every journey carries a story and every story carries guidance. Until our next journey, may Allah increase us in beneficial knowledge and guide us toward what is true.